One of the things we'd like to do at this point is kind of true you up on knowledge as far as TCP connections are concerned. So it's important to cover the basics so that we have a good working knowledge of what's available to us as far as the technology is concerned. So the basic concept here is that during TCP communication, there are 6 available TCP flags that can be utilized during packet transmission. And the basic idea here is that we can use these flags to indicate what point in the session and what active process we're going through in that session that we might be. Flags are going to indicate whether packets are SYN packets or open session requests, acknowledgement packets, finish packets, urgent packets, push or reset packets. And depending on this combination of the flags here, we can set various session connections and various components at certain times in the communication process. This will allow us to identify where we are in the communication or session establishment process and gain further information about the hosts and how they want to communicate. TCP, as a communication protocol, uses an initial 3-way handshake to establish and maintain any sessions that are necessary. And the process basically works like this. The source or originating system sends a synchronization request or a SYN packet to the host or to the target. The target is going to reply back with a SYN ACK, or a synchronization request and an acknowledgement to the initial synchronization request. So the source system is going to receive that and reply back to the target synchronization request with an acknowledgement. And it's basically, at this point, the host has sent a SYN and received an ACK, and the target has sent a SYN and received an ACK as well. So we're in a full 2-way process of communication via the TCP 3-way handshake process. Attacks or hacking techniques are going to use non-standard combinations of these flags, also known as malformed packets, to take advantage of the TCP protocol itself. And our idea here is to receive responses or particular sequences back from the target to gain information that you would not normally be able to see. A great example of this would be to send a certain packet with certain flags turned on and turned off so that the host would respond back in a predictable manner. So based on the response of the host, we can identify certain information, such as operating system or services, associated with the response over the TCP connection. An example of this process that can be used for malicious reasons is something called a SYN flood. And the SYN flood utilizes the 3-way handshake process by sending only synchronization requests to the intended target. So when the intended target receives that synchronization request, it opens a slot in RAM for that connection and sends a synchronization acknowledgement back to the originator. Well, if the originator ignores that and the 3-way handshake is never fully completed, then in theory, the amount of RAM allocated must remain open until the timeout expires. Well, let's say, for example, you have a 30-second timeout on failed TCP handshakes. Well, in 30 seconds, you can send probably around 40 million packets. So I can initiate 40 million synchronization requests before the initial synchronization request times out and the RAM is reallocated. So even if we only open 1 kilobyte of RAM for every synchronization request, not too many systems have 40 million kilobytes of RAM. So as you can see, we can immobilize that system by forcing it to open half-open TCP connection attempts, and indefinitely it will stop responding to legitimate requests or fail altogether. So at this point, you should have a pretty good idea of the basics of TCP connections and sessions and how they're established and maintained via the flags in the packets. This information is going to be extremely valuable once we get into more detail about the TCP scan types.